Here's the homework help video for the sample space and finding probability worksheet. So for number 1, for all these problems from 1 through 6, we have to find the sample space. So again, the sample space is all the possible outcomes. So for number 1, the dice roll, you can have outcomes of 1, 2, 3, 4, 5, and 6. That is the sample space, all the outcomes of the dice roll. Number 2, now there's an ice cream shop that has a sale for its most popular ice cream flavors. Customers can have 1 scoop of ice cream in a cup or a cone, and the flavors on a sale are chocolate, vanilla, and strawberry. It can be served with or without sprinkles. So you guys have to think all of the possible combinations that there are. So there's a cup with chocolate and with sprinkles. Okay. So cup, chocolate, and sprinkles. I'm also going to do, there's a cup, chocolate, and no sprinkles. Okay. So there's 2 combinations. Now we're going to do strawberry. So cup with straw, sprinkles, and we'll do a cup, strawberry, but no sprinkles. And then, of course, there's the vanilla option. So a cup, vanilla, sprinkles, cup, vanilla, no sprinkles. So those are all the combinations of the cup. And with the cone, it's going to be the same thing as well. Cone, chocolate, sprinkles, cone, chocolate, no sprinkles, cone, strawberry, sprinkles, cone, strawberry, no sprinkles. And there's also cone, vanilla, sprinkles, and cone, vanilla, no sprinkles. And there's all the combinations or all of the outcomes and the sample space for number 2. Now for number 3. Again, sample space is all the outcomes. So how many W's do we have? 1, 2, 2 W's. So there's going to be 2 W's in your sample space. W, 1, 2, 3 X's. How many Y's? 1, 2, 3, 4, 5 Y's. 3, 4, 5 Y's. And for Z's, there's going to be 2 Z's. So that is the sample space for the spinner. Okay, for number 4, a jar contains 3 red marbles, 4 blue marbles, 2 green marbles, and 1 yellow marble. The sample space is all the outcomes, so it's going to be the 3 red, the 4 blue, the 2 green, and the 1 yellow marble. Number 5, an even number between 1 and 15 is chosen at random. So the sample space for this is 2, 4, 6, 8, 10, 12, and 14. Number 6, a ball is chosen at random from the box. So what I see here is 1, 2, 3, 4. 4 solid. 1, 2, 3, 4, 5, 6, 7. 7 stripes. And 1, 2, 3, 4, 5, 6, 7, 8. 8 stars. And that is going to be your guys' sample space. All the possible outcomes. Okay, so for this one, you guys are going to construct a probability model, and then you're going to say if it is a uniform or non-uniform. So put your guys' outcomes up top and probability on the bottom. Okay, so I'm going to draw this for each one. Actually, I should have copied. Okay, so here's our probability models, and we're going to draw the outcome up top and the probability on the bottom. So on the top, the outcomes are either a plain bagel, it's going to be a blueberry bagel, a sesame seed bagel, or a cheese bagel. So those are all the outcomes. Now what is the probability of choosing one? So when you guys count the total amount of bagels, there is a total of 12 bagels. So that means all of these probabilities are going to be divided by the total, which is 12 bagels. So for the plain bagel, it's 4 over 12, which you guys simplify to be 1/3. Divide top and bottom by 4. This one over here, blueberry bagels, 2 divided by 12, but then simplify that fraction for 1 over 6. For sesame seed bagel, that's 1 over 12, and for cheese bagel, it's 5 over 12. So, are these uniform? Do these give you all the equal amount of chance to get these bagels? No, so this is going to be non-uniform. Okay. Number 2. We have a blue sock, a white sock, a green sock, and a brown sock. So there's a total of 10 socks. So that means all these probabilities are going to be divisible by 10. So 3 out of 10 for the blue. For the white, it's 2 out of 10, but simplify that fraction for 1/5. For the green, it's 4 out of 10. Simplify that fraction to be 2/5. And for the brown sock, it's 1 out of 10. So again, are these uniform? Not really, because they don't give you guys an equal amount of chance to solve for these. So this one's non-uniform. Number 3. Okay, so for the shapes, we got what? A cube, cylinder, and pyramids. Total amount of shapes, there's 9 total. So all of these are going to be divisible by 9. So there's 3 cubes, so 3 out of 9, which is 1/3. There's 3 cylinders, so 3 out of 9 for 1/3, and there's 3 pyramids, so 3 out of 9 for 1/3. Now, are these uniform? Yes, because you have the same probability chance of selecting any of these. So this one is uniform. Okay, number 4. We got an orange, we have an apple, we have a kiwi, and we have a pear. For the orange, there's 11 total fruits. So for the orange, probability is going to be where's orange? Wait, sorry. There's not 11 fruits. There's 22 fruits. 22 fruits. So for the orange, it's going to be 6 out of 22 chance, which is 3 out of 11. For an apple, it's 4 out of 22, which is 2 out of 11 probability. For kiwis, it's 3 out of 22 chance, and for pears, it's 9 out of 22. And these are non-uniform because you don't have an equal amount of chance to get all the types of fruits. Number 5. There are A, B, C blocks. So A, B, C, and D blocks. So for A blocks, you guys, how many blocks are there? There's 16 blocks, and look at there. There's 4 for each. There's 4 blocks for each. So probability is 4 out of 16, which is a fourth. For B's, there's 4 B's out of the total 16 for 1 out of 4. Same thing for C's, and same thing for D's. So are these probabilities uniform? Yes, because you have an equal amount of chance to get all of them. For number 6, we have, what is that, 12, 15. 15 total instruments. Or not instruments, sorry. for members. So there's sopranos, altos, tenors, and basses. So for sopranos, you have a 5 out of 15 chance, which is 1/3. For altos, you have a 3 out of 15 chance, which simplifies to 1/5. Tenors, that's 4 out of 15 chance, can't simplify that. And for basses, 3 out of 15 chance, which is 1/5. And this is non-uniform, you guys, because you don't have an equal amount of chance to get each one. Okay. Coming into the end. Okay, so for number 1, you spin the spinner 1 time. It's greater than 7. So I count, there's 5, 8, 9, 10, 11, 12. So there's 5 out of 12 chance that you could get greater than 7. Not greater than 7, that's going to be a 7 out of 12 chance. Because 1, 2, 3, 4, 5, 6, 7, those are all numbers that are not greater than 7. So, you have vowels from A through K. Vowels from A through K. So, A, B, C, D, E, F, G, H, I, J, K. So there's 11 total. Probability of getting a vowel. So there's A, E, L, M, wait, A, B, C, D, E, F, G, H, I, J. So A, E, and I are all vowels. So that's 3 out of 11 chance you can get a vowel. And then for not vowels, it's 8 out of 11 chance. The rest. Number 3, you choose a ball at random from the box. Probability of getting a 5. So I see 2. There's 12 total, right? I see 2 5s, so you have a 2 out of 12 chance of getting a 5. Simplify that, you guys, for 1 6. Probability of not getting a 5 is 10 out of 12, you guys, which is 5 out of 6 chance. Number 4, a coin worth more than 5 cents. A coin worth more than 5 cents. So, coins that are worth more than 5 cents, you guys, are quarters and dimes. So just keep in mind, there's 16 total here. There's 5 quarters and 2 dimes, which are more than 5 cents. So that's 7 out of 16 chance. Probability of not a coin worth more than 5 cents, that's 3 pennies and 6 pennies and 3 nickels, which is 9 out of 16 chance. Number 5, there's a total of 30 balls, half of which are shaded. You choose a ball at random from the bag. So probability that it is shaded, you guys, that's 15 out of 30, which is a half. And not shaded, you guys, which again, it's 15 out of 30, which simplifies to 1/2. Number 6, there is a total of 18 transportations, I guess. So probability of walking is 3 out of 18. Simplify that, you guys, for 1/6. Probability of not walking is everything else. 15 out of 18, you guys, which is 5/6. So that concludes that. And now you guys just have left is the counting principle. So, there are 5 students scheduled to read their essays aloud in class. The teacher will randomly choose, and how many different orders can students read their essays? So this is the counting principle, everyone. So, there's an order of 5. How many options here? 5 students could possibly read there. 4 students here, because if one's already here, you guys, there's 4 options of students to read aloud. 3, 2, 1. 120. That one, you guys, is 120. This one, so you guys have 4 options here, 3 and 3 there. Multiply all those together, and you guys would get 36. A website requires users to make up a password consists of 3 letters. So 1, 2, 3. Consists of 3 letters followed by 3 digits. So 1, 2, 3 digits. Neither letter nor digits can be repeated. How many different passwords are possible? Okay, so first we're gonna do the 3 letters. A to Z, you guys, there's 26 letters of the alphabet. So how many options can be chosen here? 26. How many here? 25. How many here? 24. So that's for the alphabet because there's only going to be 3 slots. Now you have 3 slots for digits. So from 0 to 9, how many digits are available? 10. So you have 10 options here, and then 9, and then 8. You guys multiply all those together, and you would get 11,232,232,000. Number 4, how many different arrangements in a row can you make with these blocks? So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 blocks. One, 2, 3, 4, 5, 6, 7, 8. So how many options of blocks can be put here? 8, and then 7, 6, 5, 4, 3, 2, 1. For a grand total of 40,300 different ways. 320 ways you can have a change. Okay, Gina has 12 favorite songs. She sent her audio player to continuously play songs randomly, selecting a song each time. How many different possibilities are there for the first 5 songs that come up? Okay, so basically, how many different songs can be played for the first 5 songs? Well, if it's by random, you guys, the possibility of one coming back up is possible. So for all 5 choices, you guys, it's 12. 12 for the first choice. And then since it's playing randomly, the 12 options are still available for each one. So 12 to the 5th power, you guys, is 248,832. For 6, you spin the spinner shown in the diagram 5 times. How many different outcomes are possible? Well, you spin it 5 times. And there's 6 possible outcomes total each time. So multiply all those together and you guys would get 7,776 different ways. For 7, photograph 12 members of a soccer team. How many different arrangements? Well, there's 12 slots, you guys. 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 slots. How many members can be for the first spot? 12, second, 11, and so on. And when you guys multiply those together, you guys would get 479 million and 1,600 different combos. And number 8, 4-digit code. 1, 2, 3, 4. How many different codes are possible with each slot? And you can have repeats. So 10 options, another 10 options, another 10 options, another 10 options, because you can have repeat of a number, which you guys for this one is 10,000. So I hope this helps you guys, and this is a good amount of stuff, but it's something that is doable. Alright, good luck.